light from a monochromatic source is incident on a single slit. The intensity of the source remains the same. The width of the slit is increased, which graph correctly shows the variation of intensity after the change. The original curve is dashed line. So the only formula for single slit diffraction is the next. B sine theta is k lambda, where b it's the width of the slit and theta it's angle at which minima occur. And the first change it's about what width of the slit. It's just literally more light incident on the screen, greater intensity is. So intensity will be increased. So it's A, B are not correct, so it's C or D. And the second change is what? Which it's the same. The width of the slit is increased, so B increases. But what is the difference? You can see that the difference is in position of the first minimum. It will be closer to the center or further away. How to do that, or how to find out? Sine theta is what? K lambda over what? Over B. And if B increases, what? Sine decreases, and sine decreases, and the angle with respect to sine from unit circle, actually from 0 to 90 degrees, sine it's what? It's y coordinate. You can see that it's increasing function. So if sine decreases, theta is also decreases. So position or angular position of the first minimum decreases. So nu it's solid, so it must be like this. This position should be at the smaller angle. So it's not correct. So it's D. The next, monochromatic light is incident on a diffraction grating. The diffraction pattern from the diffraction grating is then formed on the screen. Only the central maximum and the first order maxima can be observed on the screen. What change will allow the second order maxima to be observed on the screen? So diffraction grating, and we will observe what? Bright fringes, narrow bright fringes on the screen. For one slit there will be actually everything will be bright, but dark fringes. So it's light, dark fringe, so this bright will be a white region. Here it will be small intensity, but it's bright and dark fringe. But here there will be only bright, narrow, bright fringes. And the angular position of the corresponding bright fringe, we use the formula. What formula? D sine theta is equal to k lambda. For one slit, this formula B sine theta is k lambda. It's for dark or minimum, and it's for maximum or bright fringes. Actually there are only bright fringes. And what is D? D it's from this to this distance, D. For example, for one it's this angle, theta, and it is given that there is only central and first order, but first order can be in one and in opposite direction. So there are three fringes in total, actually. But we need what? The second to be present. Second here and second here. But now if we try to calculate the angular position theta for the second, this equation becomes like this. D sine of some theta is equal to 2 lambda, and sine theta is 2 lambda over d, and now when k is 2 there are no solutions, and we should make some changes so that we should get the solution to be present. And what changes can be made? Decrease the distance between the diffraction grating and the source. No, the screen source. It doesn't influence on the position or positions of fringes. It influences on intensity. So definitely it's not A. Increase the distance between the diffraction grating and the screen. You can see that there is no distance between screen and the diffraction grating on the right hand side here. This distance arises only when we use small angle approximation and sine theta is approximately equal to tangent theta, and it is equal approximately to just theta in radians. And what is tangent? Tangent is opposite over adjacent, so it becomes some distance s over this distance d, and d is distance from the grating to the screen. But definitely it's not correct answer here. Increase the wavelength of the monochromatic line. And again, previously we have no solution. Why? Because sine is greater than 1, hence no solution. But to get a solution, sine must be what? Less than 1. So we should what? We should decrease this value. And this option say what? To increase the wavelength. If we increase lambda, sine becomes larger. But it's already greater than 1 because we have no solution. We need decrease this sign. Decrease this sign. So definitely it's not correct. Reduce the number of lines per unit length. Number of lines is just 1 over d. It's n is 1 over d. So d is 1 over n, and it becomes 2 lambda n. And if we reduce, if we reduce the number of lines per unit length, if we reduce n, sine, which is now greater than 1, will also reduce, and it will be less than 1, and there will be solution for theta, so that there is such theta which corresponds to the second maxima. So D is correct. And that's all for this question.